Thank you for attending my talk. The topic of today will be TDD and GenAI, and together we're going to see if this is a perfect pairing. So I would like to start with a little introduction. Why am I here talking about this subject? So my previous talk was called The Battle of the AI Coding Assistants. In this talk, I compared different AI coding assistants. I showed off features. Think GitHub Copilot, JetBrains AI Assistant, but also good old JetGPT. One of the features I showed off was the fact that they are pretty capable of generating test cases. So how did it work? I
cannot hear you clearly. It's wobbling.
The echo.
Audio is not clear.
Voice is echoing.
Echo. Okay. I'm not sure how to fix that. So there's a lot of buttons over here, but I'm really afraid to press them. Is it better? Oh, I should talk. 1, 2, 3. Mary had a little lamb. 1, 2, 3. Is it better? Otherwise, I can also do it without the mic. But yeah, good enough? Everybody happy? Okay. Where was I? Yeah, I was talking about. Whoa, that was horrible, right? Okay, still okay when I'm from here? Okay, cool. I hear the echo as well. Pretty sure it's okay? Okay, now let's do it. So I was talking about my previous talk, the Battle of AI Coding Assistants, and the fact that those are pretty capable of generating test cases. How does it work? One provides an implementation, gives it to AI, and asks for test cases. In almost every case, it comes up with the happy flow. In most cases, it comes up with some edge cases. And if you're still not happy, you can ask for more till you have a nice full test suite. So I gave this talk at multiple meetups, multiple conferences, and after one of those conferences, somebody came up to me and said, "Hey Bouke, thank you for your talk, but why don't you do it the other way around?" And I said, "The other way around? What do you mean by the other way around?" Now she said, "You write tests, you give them to AI, and you ask for an implementation." And I said, "Wow, interesting idea. I don't know, but I'm going to investigate." This investigation led to this talk. So the second thing I would like to do is a dissection of the title. So let's repeat the title. TDD and GenAI, a perfect pairing. So there are 3 IT concepts in this title, and the first 2, of course, are plain obvious. The first one being TDD, test-driven development, and the second one being GenAI. So who dares to venture a guess what the third IT concept? Little bit. Pair programming. Thank you. You're a great audience. So of course the third one is pair programming. So we're going to try to combine those 3 concepts into something new. But before we're going to do that, I'm first going to take a minute to talk about all those 3 concepts so we're all on the same page. So the first concept is GenAI, and JetGPT is the most famous one. It was introduced a little bit over 2 years ago, and a lot has changed since then. All major IT players have their own AI coding assistants, and they all run on a technique called a large language model. And those models are pretty good at generating text, but also pretty good at generating code, and that's what we're going to do today. The second one is test-driven development, TDD. People hold entire conferences about the subject, but for this presentation, I'm going to boil it down to writing tests in advance. This is better than the other way around for a lot of reasons, but there are 2 reasons I really like. And the first one is the fact that if you first write your implementation and then your test will be biased. We do not want biased tests. Secondly, I really believe in the following: the more you think about something, the better the end result will be. If you first write your test, you think a lot about your implementation, therefore you will write a better implementation. Also, it works really well with pair programming, so let's talk about pair programming. Now, pair programming is pretty simple. You write software in pairs, you sit together behind one keyboard, fixing bugs, creating features. Normally we have 2 roles. We have the driver, that's the person sitting behind the keyboard, typing the code, and we have the other person called the observer or navigator, and that's the person who will give light feedback on your code, and that's the person you can have a discussion with while you're writing the code. Also, a thing that happens a lot when doing pair programming is that one person writes the test, you switch chairs, and then the other person will write the implementation. So let's see if we can combine those three concepts. Sorry about that. Those three concepts into a perfect tripling. This is the idea. We're going to pair program with GenAI. The human will write the test, and AI will try to write the implementation. I call this test-driven generation, TDG. So something we didn't talk about yet is the fact that tests have a double purpose. So we talked about the first purpose. We're going to use test as input. So we're going to give the test to AI, and we're going to ask for an implementation. But there's also a second purpose. We're also going to run the test afterwards against this implementation to see if the LLM came up with a correct implementation. And this is really important. You all have been playing with LLMs in the last 2 years, and you all have seen that sometimes LLMs make things up, and that's a problem, especially when you're generating code. People who are looking for seats, there are some seats over here, so you can sit here. You can also stand, whatever you like. But let's give you an example of, let me tell you a little story in which it becomes really clear why it's important that we check LLMs for correctness. So the story was in the beginning of last year. It's about a company called Air Canada. It's an airliner, and they have a website. On their website, there is a chatbot, and they decided to improve their chatbot by using an LLM. And this in itself is a proper idea, because when you're using an LLM, your chatbot will give more natural, more human-like answers. So a customer was chatting to this new improved chatbot, and they were talking about refund policies. And as you probably already imagined, the chatbot started to make up its own refund policy. It's invented one. So the customer was kind of foresighted. He made screenshots, and then a few weeks, nothing happened. Until the customer decided to make use of his until the customer decided to ask for a refund for his ticket. So he called the actual help desk with actual humans behind it, and he asked for a refund. And the people behind the help desk said, "Sorry, sir, we cannot give you a refund. You're not eligible." I said, yes, look, I have screenshots. I talked to the chatbot, and the chatbot clearly stated that I could refund my ticket. And the people behind the help desk said, "Sorry, sir, the chatbot made a mistake." So the customer did not agree and went to court. The judge totally agreed with the customer, and he said, "I don't mind if a human or a chatbot puts stuff on your website. If it's on your website, you have to honor it. Therefore, you have to refund the ticket." So the next day, the ticket was refunded and the chatbot was offline. And I think this story really illustrates, somebody's working on it. So in the worst case, I can just talk a little bit louder. My voice is loud enough. So this story clearly illustrates what's currently wrong with LLMs. So don't get me wrong, I love my LLMs. I think they're great tools, but we can trust them up to 80, maybe 90%. And the problem is in the last part. We cannot trust them for the full 100%. So you should always check the output of LLMs. Lucky for us, in this idea that I'm going to present today, we're going to use tests to check for correctness. So we have an automated way to check for correctness. We can check the answer of the LLM. Okay, my name is Bouke Nijhuis. I'm from the Netherlands. I'm the CTO at a company called Sync ICT, and today we're going to talk about TDD and GenAI, and we're going to see if this is a perfect pairing. So I created a little schema to show off the way of working. I'm going to start with the happy flow. That means I'm going to start on the left and then I go to the right. Afterwards, I will talk about the loops in the model. So we start with tests. Tests are input. We feed the test to GenAI. We ask for an implementation that will pass the tests. And remember, it's happy flow. Therefore, AI will come up with a perfect implementation. And we're currently in the box in the middle. Again, this is happy flow. Therefore, all tests will pass. We follow the yes arrow, and we're done. If you trust your test, you have production-ready code. This is how it should work in theory. Unfortunately, we live in something called practice, and in practice, things go wrong. That is why we have loops in the model. So let's start with a small loop underneath GenAI. I call this the code loop because we're trying to get code. We need this loop because sometimes GenAI comes up with an explanation instead of an implementation. Sometimes GenAI comes up with partial or non-compiling code, so we have to ask it sometimes a few times to get proper running code. Sometimes not all tests pass. This is the big loop on top. I call this the test loop. If this is the case, we extract all failing tests, including their logging, including the stack traces. We feed it back to GenAI, and we ask for a better implementation that will also pass the test that failed in the previous run. And this is how you get a feedback loop. So, demo time. I have a question for the audience, and you can choose which LLM I'm going to use for the next two demos. In the past, you could choose between JetGPT from OpenAPI and Cloud Sonnet from Anthropic, but last month was all about DeepSeek, so that's why we have three options. So please raise your hands if you want me to use OpenAI. Okay, 5%. Please raise your hand if you want me to use Sonnet, Cloud Sonnet. I would say less. Please raise your hand if you want me to use DeepSeek. I think DeepSeek barely wins. Okay, what is all the other people, what do you want me to do? Because there was, I would say, less than 20% of the people did something. But okay, we're gonna use DeepSeek. And, sorry, what? I don't have Copilot, so sorry for that. I'm Dutch. Dutch people are cheap. I don't pay for stuff, right? So, sorry for that. We're going to start really simple with an odd-even test. And don't worry, things will become more difficult during the presentation. Yes, question?
Does DeepSeek observe the OpenAI specification?
Yes, I think it does. So odd-even test, let me show you, really simple. Odd-even test. So we have a JUnit 5 test here. We expect a class called odd-even to be there. It should have at least one method called isEven. If you provide it with an even number, it should return true. And if you provide it with an odd number, it should return false. So no rocket science here. I'm gonna copy the code. I'm gonna go to DeepSeek. I'm gonna say, please provide an implementation that will pass this test. And I'm going to paste the code. DeepSeek is really nice because it shows you its reasoning process, but it's also really slow. So let's do a plan B. Please provide an implementation that will. For people who do not recognize this, this is Cloud Sonnet. Actually, it's Cloud Haiku. It gave me an error this morning. It was pretty busy on their server. Probably it's good enough. It's still thinking. So that's why I have a plan B. So for now, I'm going to copy this one. Just going to copy it. I'm going to go back to my IDE. I'm going to go to the test subject. I'm going to select everything. I'm going to paste the code from DeepSeek. I'm going to go back to the test. And I'm going to run the code. And I'm going to hope for a green check mark in the bottom left corner. And look at that. Green check mark in the bottom left corner. Really cool. The principle works, but this was, of course, a really simple example. So let's step it up a notch. So what we're going to do prime number generation. I have a test for that as well. Prime number generator test. And let me make some space. Now, notice that we now have two tests. First one is called under 10. It expects a prime number generator class to be there. It should have at least one method called generate, and it takes an integer as input. This integer denotes the upper bound of prime numbers to generate. So if you put 10 there, we expect it to come up with 2, 3, 5, and 7. I have something similar with 50. If we put 50 there, I expect this list of numbers to be returned. Okay, again, I'm going to copy everything. Let's see if DeepSeek is true. It's done. Where's the, oh yeah, it's done. Okay, I'm just going to paste it. The AIs are pretty smart. They know I'm still asking for an implementation that will pass this test. I don't have to repeat my prompt. I'm going to do exactly the same here. Because of speed reasons, let's see what's happening over here. Thinking, talking, thinking, talking. And of course, you could unselect this button over here, then it will be faster. But let's see. Hey. Claude is already done. I'm going to copy it. I'm going to go again, do exactly the same. Go to the test subject, select everything, paste the code from Claude, back to the test, and let's run the test. And now we have 2 green check marks. Cool. The principle works. So you can provide test cases, give it to AI, and ask for an implementation. Thank you for listening to me. Enjoy the remainder of the conference. No, just kidding. Fortunately, everybody laughed. Almost everybody laughed. There are 2 major issues with this approach, and the first one being the fact that there are too many manual steps. So let me rehash what I did. I copied code from my IDE, I went to the browser, I typed the prompt, I pasted the code, I pressed enter, waited for the answer from DeepSeek, so I had a plan B, got an implementation, went back to my IDE, went to the test subject, selected everything, pasted the code, ran the test, and wait for the output. Just talking about this makes me tired. So far, too many manual steps. What do we do when we have too many manual steps? We automate, we automate. Very good, let's automate this. So that's what I thought. Sounds pretty simple. There are a lot of steps, but you saw me, it's a little bit in the IDE, it's a little bit in the browser. So in my mind, it was 3 to 5 evenings. Boy, was I wrong. It turned out to be harder than I expected, like a real project. So in the end, I spent 10 to 15 evenings and a few weekends, but I learned something. I learned that the IDE does a lot of work for me. Of course, I already knew that the IDE does a lot of work for me, otherwise I wouldn't use it, but it became really apparent while building this tool. But in the end, I had a tool called the test-driven generator, which I of course will show off in this presentation, but first I want to take you to all the small little steps that it takes. So you probably recognize this as part of the scheme I've shown you before. And the first thing that we need to do after reading the tests from a file, we have to call an API of a GenAI. So I started building this tool in the beginning of last year. I was most familiar with JetGPT, so I started out by using the API from JetGPT. And this is not difficult, but it's work. It takes a little bit of effort to set it up. Then you have to interpret the reply. And this sounds really simple. You saw me in the browser, you saw explanation, implementation. The implementation was separate from the explanation, so I could just press the copy button. But this is not the case with all LLMs. So at this time, I also got interested in local large language models, so the ones just running on my machine, not in the cloud, and they're less powerful, they're just more difficult to use. And they all use a different way to make the distinction between explanation and implementation. So I needed to come up with a way to interpret the replies that would also work for local LLMs. More about that later. Then you have to create a file. And I'm assuming most of you are Java programmers, engineers, and in Java, when you want to create a file, the file name should be equal to the public class name. So I needed a feature to extract the public class name from the code that the LLM generated. So I could create the file in a temp directory. The second thing I needed to do is, if your generated implementation contains the package keyword, I need to extract the part behind the package keyword, create a corresponding folder structure so I can put the file in the right folder. Not difficult, but work. Then I had to compile both files, so the test file and the generated file. I totally forgot about compiling files. This is typically something that the IDE takes care of for me. The last time I manually compiled files is probably more than 10 years ago. And now I had to compile files from Java code, which I had never done before. So that took me another evening. Then you have to load both classes into the JVM. Loading classes in the JVM, who's doing that nowadays? That's also typically something that the IDE does for you. So I also totally forgot about the fact that I had to do that. I had to write my own custom class loader. Then I had to load the test library. So normally when I start a project, I just put JUnit5 in my POM file and forget about it. And you give it the test scope and you're done. But now it shouldn't have test scope because we want to use it while we're running the tool, not while we're running test. So I totally forgot about the fact that I had to load a test library to be able to run tests. Then you have to run tests from code. Also something I never do. I normally press the green triangle and then it just runs. You can run tests from code. I never did it before, so I had to look into it. But in the end, I was able to run the tests from code another evening. Then once all tests pass, I copy the implementation generated by the LLM, back from the temp folder where I do all the stuff to the project where the test file is, so you can directly use it. Last slide with steps. If not all tests pass, you have to extract the errors. In IntelliJ, you get this nice table, you get green check marks, red crosses, or yellow crosses nowadays, and you can clearly see what's wrong. And now I have to extract errors from a memory structure, grab all the logging, make it into one big string, and give it back to the LLM. Then you have to continue the conversation, and when you're talking with an LLM in a web browser like I did with DeepSeek and Claude, it remembers what you talked about before. It keeps track of context. This is not the case when you're using an API. Every call is a new call. It doesn't know about the old calls by default. So another evening. Proper logging. So I started out with a few system out print lines, like every project, I think. And remember this schema with the loops in there. Every time when you make a loop, the input is a test file containing several lines of code. The output is explanation from the LLM implementations against a lot of lines of code. If you make a few loops, you go to 100 or 1,000 lines of stuff that you want to save. So I created detailed information in a log file and a summary on the console. So hopefully you now understand why it took me a little bit more than 3 to 5 evenings. So I just mentioned local LLMs, and I learned 2 things with playing with local LLMs. Yes?
You forgot to ask for a coffee to be brought.
When?
Well, in the beginning, while it's working, all of these things.
Ah, very good. You saw my presentation online, or? I'm dropping something. Yeah, I did. Insider joke. I will. Let's continue for now. So local LLMs. I learned 2 things with playing with local LLMs. First of all, they were far easier than I expected, but also much faster than I expected. So what did I expect? I expected setting up a local LLM taking like 20 manual error-prone steps, and then hopefully it will start up and work. It turns out there's a tool out there, Olama, which is like the Docker for LLMs, and it just works. You install it, you download it, and it runs. Perfectly cool. Also, I expected answers to take up 2 minutes before the LLM would answer. At the moment I started playing with this, I had an Apple M1 Pro. Answers took up to tens of seconds, so 20, 30 seconds. Nowadays, I have an M3 Max, and answers now take around 10 seconds, which is pretty amazing. So there are lots and lots of local coding LLMs out there. I tried a lot, but in the end, I settled on Llama 3.1. I know this is not the latest model. I know there's a 3.2, there's a 3.3, and I know there are all kind of newer models, but the newer models don't really improve, don't work better for my use case, so I still use Llama 3.1. This is the model I'm using while doing demos, unless I specify something else. And I'm using the 8 billion parameter model because it runs pretty fast on my machine, so you don't have to wait too long. Okay, demo time. This is for me. I have to do a git reset. So I'm getting rid of the answers from Claude. And so we have a clean slate. So what am I going to do? We're going to do the prime number generator test again, but now we're going to do it with a tool, so without all the manual steps. And the tool in its current form is a jar file. It's just somewhere on my machine. And its most important input is a path to the test file. So I'm going to copy the path that's over here on top. I'm going to paste it over here, and I'm going to press enter. And notice that there's a test loop and a code loop. I told you about those. So within a test loop, you can have 5 code loops, and in total, we can have 5 test loops, so 25 attempts in total. Now look at that. The machine is too fast. I don't have enough time to explain. Within 6 seconds, it came up with a solution. We can take a look at the solution, but we don't really have to. Because if you trust the tests, you trust the output of this tool. Okay, cool. The tool works too. And this is really cool because now I don't have to do all the manual steps anymore. And I can just use the tool and play with it. Let's talk about the implication of having such a tool. So how would you add features? Now, in the past, I would just go to the implementation, write more code to implement features. But hey, the implementation is now the area of the LLM. I'm not allowed to touch it anymore. The only thing that I'm allowed to do and to touch is the test area. So we just write more tests. And this feels really natural when you're used to working TDD style. So let's do a demo with that. Let's talk about negative prime numbers. So remember that I told you this number denotes the upper bound of the prime numbers to generate. So if you put a negative number here, you're asking for negative prime numbers. As far as I know, they do not exist. Therefore, I want the tool to generate, I want the LLM to generate an exception whenever the user asks for negative prime numbers. So how do you do that? You add a test case. And I'm going to do that here. Notice this is the one-line code completion from IntelliJ. I love it. It says you want an over 50 method, which is wrong, but I understand where it's coming from if you have an under 50. I'm going to call it negative input. Then it says, hey, probably you need a prime number generator. Totally correct. I'm going to press tab. I don't need this. What I need is an assert throws. And again, IntelliJ, the one-line code completion comes up with a perfect solution. I'm going to accept it, and then I'm going to explain it. So an assert throws takes two parameters. The first parameter is an exception that you expect. So in this case, I expect an illegal argument exception. I see the people in the back have difficulties reading it. I try to scroll a little bit up. Then you provide a lambda that should call the code that should throw the exception. So notice that I put a -1 here. So if I'm asking for negative prime numbers, please throw an illegal argument exception. That's actually what the test says. So we go back to the terminal, I rerun exactly the same command. The only difference is that it now points to a file containing 3 test cases. Oh, it's already done, wow. So within 4 seconds, you can see it found 3 test cases and all 3 of them succeeded. Now let's take a look because I want to see if there is what changed in the code. I'll go here, I go to the test subject, and these 3 lines I added because I added a test case. So you add features by adding tests. And again, this feels really natural. So what about real code? So up till now, we talked about toy problems, right? We talked about odd even, we talked about prime number generation, and I think the last one, so the negative with the negative input, is not really a toy problem, but was an interesting problem. But what about real code? I assume, again, most of you are Java programmers, and you've all written tens of thousands unit tests in your life. You could feed those unit tests to this tool, and maybe it comes up with something better than you wrote. And actually, that happened in my case. I used the tool to improve this tool. Let me explain that. So somewhere in the tool is a class called the code container, and it has a few features. The first feature is the fact that it holds the code that is generated by the LLM. But then, I told you before, I need, if Java file names should be equal to the public class name. So I need a feature to extract the public class name from the generated code. Secondly, if the generated code contains a package, I need a feature to extract the part behind the package keyword, so in a later stage I can use it to create a folder structure. And so what I'm doing actually is I'm extracting text from text. And in most cases, the best way of extracting text from text is by using a regular expression. Confession time, I am really bad at regular expressions. I think they're really hard. I think they're written for computers, they're not written for humans. Therefore, I wrote a really poor man's substring implementation. And this one worked for a time until I added a few more test cases, and then it kept breaking and breaking. So I decided I needed a proper implementation for the code container. And I was thinking, why not use the tool to improve the tool? So let's take a look at the code container test. So there are 2 tests in here. The first one is called file name extraction. And what it does, I have a few small classes here. Notice that I have classes, I have public classes, but also notice that I have spaces in random spots. Those spaces in random spots really broke my poor man's substring manipulation solution. Notice that I have answers over here, and notice that I have messages. I think having messages with tests is really nice for the person who will maintain the code after you wrote it. But in this case, if you put the right message there, it also helps the LLM to come up with a better implementation. So that's why they're there. I have something similar for package name extraction. So notice I have a few small classes. Notice again, random spaces in random spots. Notice single level packages, multiple level packages. Notice no package. Package is optional in Java, right? And again, we have the answers and the messages. So what I'm going to do, I'm going to copy the path to this file. I'm going to go to the terminal again. I'm going to get rid of the last input and I'm going to paste the path to the file on top and I'm going to press enter. So I'm talking, the tool is talking to Claude 3.1, 8 billion parameters on my machine. Oh, and it's already done. Normally I tell you, this is on the edge of what an LLM, a local LLM can do, but today my local LLM is on fire and everything works. So that's nice. Now let's take a look. I have to warn you, sometimes there are working string manipulation solutions out there. So sometimes it comes up with a working string manipulation solution. I hope it came up with a regular expression solution. Let's see what happened. Ah, look at those nice unreadable regular expressions. So, sorry, I used the tool to improve the tool. And so yeah, you could also feed your tests in there to see what happens. So at the beginning of this talk, I said I had two major problems. And the first major problem was the fact that there were too many manual steps. So we automated that away. The second problem is now I have a tool that's pretty good at generating plain Java code. But that's not really what we do at work, right? That's not what we do at our daily job. We use libraries and frameworks. And currently the jar file I've just shown you cannot handle libraries and frameworks because the only input that it has is a test file. And you cannot deduct all your libraries and frameworks from a test file. You can, I think you can find some, but not all of them. So I started thinking about this problem, which part of my development cycle knows about my libraries and frameworks. And if you think about it that way, it becomes really simple. The build system knows about all your dependencies and therefore about your libraries and your frameworks. So I decided, let's create a Maven plugin to solve this issue. I wrote a Maven plugin because I'm far more familiar with Maven than I am with Gradle, but it should also work for Gradle. So the reason to write a Maven plugin is because it knows about your dependencies. I also expected it to load all my dependencies for me. I never wrote a Maven plugin before in my life. This turned out to be a wrong assumption. It does not load anything for you. But because you're a Maven plugin, you have easy access to all your dependencies. It's just a list of strings with paths to jar files and to directories. So I wrote my custom class loader to load all the dependencies, and then I reran the tool again. Let's see if this works. And what I'm going to do, we're going to use Spring Boot. I'm pretty sure everybody's familiar with Spring Boot. It's a pretty famous library. And I created a test called an endpoint test, but the name could also be a Spring Boot Hello World test. So let's go there, endpoint test. For people who do not know Spring Boot tests, you can ask for a random port. If you do that, it will be put in this variable. Then I need a test REST template because I want to do a REST call. And notice that I do a get on the root of localhost. And if you do that, I would like it to return hello world, like Spring Boot, hello world, example. So I told you it is a Maven plugin, therefore we should talk about the POM file. And there's a lot of stuff in the POM file, but most importantly, there's a new plugin called the Test-Driven Generation Maven plugin. And its most important input is a path to a test file, like with the jar file. Let's run it. So we go here, we say Maven test-driven generate. This is how you call the Maven plugin. And as you can see, the Maven plugin is just a wrapper around the jar file. It just reuses the jar file. But before it runs the jar file, it first loads all your dependencies. And look at that, build success in 5 seconds. My local LLM is really on fire. Like normally when I give this presentation, at least something breaks. But yeah, nothing breaks. Let's hope the next demo breaks. Okay, now let's take a look at the implementation. Sorry, wrong button. So it created a file now here, endpoint application. So it is a Spring Boot application. We have to start the Spring Boot application. There is a REST controller. If you do a get on slash, it returns hello world. This is more or less how I would have written it myself, but I need more than 5 seconds. Okay, cool, the Maven plugin works, but again, this was a really, really simple example. So let's step it up a notch and let's talk about the endpoint H test. So it's pretty similar, everything is the same, the difference is over here. So the idea is, there's an endpoint, we provide it with a birth date, and I want the endpoint to return the age. Now let me talk you through the examples. If you're born on the first day of this year, you're 0. If you're born on the first day of 2020, you're 5. First day of 2000, you're 25. But the last day of 2000, you're 24. You still have to become 25, and this is where the difficulty lies in transforming a birth date into an age. Notice that there is an age endpoint. Notice that the birth date should be part of this URL. And this is it. So I have to update the POM file because it now points to the endpoint test. I want it to point to the age test. And I rerun exactly the same command. This is really on the edge of what a local LLM can do. Oh, luckily, look at that, not a one-shot solution. So it has to use Spring Boot, which is an extra layer of complexity. It has to create an algorithm that will transform birthdays into ages, and it seems failing. So what is the first thing that you do when it doesn't work? Now the first thing that you do, you retry, because retrying is really a viable option when using LLMs. They have temperature, and every time they come up with a solution that is a little bit different. The second thing that I would do if it fails, I would check the log files. Why? Because there could be a bug in my tool, but there could also be a bug in the test file. I once had a typo in the test file, I didn't compile, and therefore it didn't work because I couldn't run the tests. So this is why you look at the log. Also, you can see I'm using Llama 3.1. You see part of the prompt, you see my input, but you also see part of the answers. Let's see if we can find why it fails. So it came up with this implementation. This looks right, age, birth date, that's right. Wow, this is really difficult. So this is just an incorrect implementation, therefore the test will fail. So the third thing that you can do whenever it fails, so first you retry, then you check the logs, and the third thing you do is you upgrade the LLM. And don't get me wrong, I'm really happy with my local LLMs, I think they're great, but the cloud LLMs are so much more powerful. There's powerful hardware, powerful models, they're also faster. So what I'm going to do, I'm going to uncheck this thing over here, and then it will use Cloud Sonnet in the cloud. So I'm going to run exactly the same command, and the difference is, in the previous demo it talked to my local LLM, but in this demo it will go to the cloud. Let's see if I can prove that. So now, it used to say Llama, now it says Anthropic, and it says Cloud 3.5 Sonnet, sorry for that. I know there's a 3.7, but I didn't update the tool yet. And look at that, it came up with a solution in 10 seconds. Let's take a little look at the solution. Now we have an age calculator as well. And now it picked up the fact that birthday should be part of the URL. It parses the incoming date, and then it made a mistake. See this? What I would have expected here is today. What you want is, you want subtract, today minus the birth date, and then you get the age. So it said fixed date as per test case. This happens most of the times. And this is my mistake. This is not the mistake of the LLM. There are two ways of fixing this. The easiest way and the fastest way to doing this is by adding a hint in the code. Dear LLM, please don't do this. Use today when you're subtracting dates. The other way to solve it, and it's the better way, but also the more time-consuming way, is adding more test cases. I only had 4 test cases for a problem that is kind of difficult. So I should have added yesterday, I should have added today, I should have added tomorrow, and then it probably would have come up with the right solution. For time purposes, I'm not going to fix it now, but believe me, if you add a hint or if you add more test cases, it will solve the issue for you. So the Maven plugin works too, and this is really cool, because now we have a tool that we can just use at our daily job. Question?
Have you tried the same test cases with Copilot? Or
No, I did not. Because you mean which Copilot? You mean GitHub Copilot? No, sorry, I don't have a subscription for that. But it's all LLM based, right? So it's kind of similar. They give the similar answers. So what does work well? Plain Java code. The first few demos were plain Java code, and that works really well. Also, if you work with well-known dependencies, using the Maven plugin should also work really well. What does not work well? References to your own code. So let's say you have a really nice utils class with all nice utils in there. The tool, the LLM, doesn't know about your utils class because we only send the information in a test file. We do not send your entire project context. A little bit more about that later. Also, if you use dependencies that are not that well known, that do not have a lot of examples on the internet, the LLM will not know about it, therefore it will probably not use it right. What if it doesn't work? Now, luckily it happened once during the last demo. First you retry, then you check the logs, and then you upgrade the LLM. But what if upgrading the LLM is not enough? Now, luckily, we have the unit test. Let me explain that to you. In the past, I would write my test, grab a cup of coffee, there's the cup of coffee, write the implementation. Nowadays, I write my test, run the tool, grab a cup of coffee, and when I come back, if it's done, it saves me a lot of time. If it's not done, I only lost 1 minute. There's not a lot of time to lose. Pricing. So it's pretty non-existent when using a local LLM, which is not entirely true, of course, because my laptop becomes a little bit hot, my battery dies a little bit sooner, and therefore my electric bill at the end of the year will be a little bit higher, but you probably will not notice it. You pay a small price when you're playing around with those tools. So creating this tool, practicing, talking at conferences and meetups cost me about 12, 13 euros, which I think is pretty acceptable. Then it will become pricey when you're using online AIs a lot. So when you use this tool for every test case that you write, it will cost a lot of money. But I really think this will be cost effective in the near future for 2 reasons. First of all, those LLMs are getting better, faster, and cheaper every week, literally every week. Also, the most expensive part of a software project is you. Your hourly rate is the most expensive part. So every hour that you save saves a lot of money. And by just saving 1 hour, you probably can use an LLM for a month. So I really believe this will be cost effective in the near future. Can I use this myself? Yes, you can. I will share 4 links afterwards. On the last slide will be QR codes, and then you can play with it yourself. I have to warn you though, it is proof of concept level. I wanted to create something fantastic, that production grade, that works always. But as I told you before, it took a little bit more time than I expected. It's good enough to play with it, it's good enough to play with the idea, but it's probably not good enough to put it in production. So I have a few bullets, I have a few ideas how I would like to improve this tool in the future. So currently it only supports 1 test file as input. I would like to be able to give more test files because that's what sometimes happens. Currently you can only put a test file as input, but if you could also put the entire project context in there, the LLM would come up with so much better answers, so this would be a nice addition. Currently, it only works when the output of the LLM contains exactly 1 class. If it contains partial code or 2 classes, it doesn't work. And I think I should be able to fix that. And then we need less loops to come to a nice solution. I would love a hybrid mode. So you write parts of the implementation but leave to-dos for the LLM. And then the LLM can do the boring work. Currently, it only supports Olama, DeepSeek, Anthropic, and OpenAI, but there are so many more interesting AIs out there, so I would like to support them all. Currently, it only supports JUnit 5, but what about 4? What about Spock and all other great test frameworks? Currently, it only works for Java, but the principle holds, of course, for every programming language out there. If you have something to test, you can use this idea. My endpoint for this idea is an IDE plugin. So picture this, you write your code, you right-click in your IDE, you say generate code, you get your coffee, you come back and you're done. Feels fantastic. I specifically said it's my endpoint because I think this should be part of Copilot, AI Assistant, or Devnexus Genie. I think they're all moving to there by using the agents nowadays, agents that can change files. Who knows about Devnexus Genie? Oh wow, it's apparently, yeah, one person. It's a European thing. So Devnexus Genie is created. Who knows about Devnexus Belgium? Okay, a few more hands. So Devnexus Belgium is a pretty big conference in Europe, and the founder of Devnexus Belgium is called Stefan Janssen. He created Devnexus Genie. It's a plugin for IntelliJ to use LLMs. It's a free, it's like GitHub Copilot, but then for free. So that's what Dutch people like, right? It is open source. My code is open source, and Stefan Janssen asked me, can you merge it? And I would love to, but I don't have the time. So if somebody would like to merge those open source repositories, you probably can talk next year in Devnexus Belgium in Antwerp on a conference. So if you want it, this is your chance. Conclusion. TDD and GenAI is a perfect pairing. The principle works. I've shown off multiple demos in which I wrote tests, gave it to AI, and it came up with implementations. We ran the test, all the tests passed, therefore production-ready code. The most important thing I can teach you today is that you always have to check the output of large language models. You already knew that, but with this idea, we have an automated way of checking the output, which is much more nice than doing it yourself. So thank you for listening to me. There are 4 QR codes in the bottom. The first one on the left is a link to the slides. The second one is a link to the examples, the coding examples. The third one is a link to the repository that creates the jar file. And the fourth one is a link to the repository that creates the Maven plugin. So if you have any questions, I prefer my questions one-on-one, so please ask them afterwards here at this nice desk. And feedback is more than welcome. I'm not sure if there's an app or anything, but otherwise just talk to me in the hallway or come to here. Thank you for listening to me. I hope everybody learned something new and enjoy the remainder of the conference. Bye-bye.